Hold on. I missed like all of that.
We just got on. I was
okay.
asking her to round up a number for me because I stink at it. Confuses me.
So, really fast, I think it's 0.060.
That's what I was thinking. Weston, would you like to confirm?
Sure. For which one?
It's actually a quiz question. Yes, it's question 14.
Oh, we're on the quiz. Okay.
Why?
I'm sorry. Can we just jump into the quiz, even though I don't understand any of it?
Yeah, you can do that.
Because all of us don't have enough time today.
No.
Never do we have time.
Okay, for number 3.
He's good. Mary, are you quiz?
Just the first 2, correct?
Correct.
Okay.
I just barely finished reading it and I got 4:30. And then I get on and start the quiz ahead of time. I can make sure before time after another classes.
Is number 4 T?
I think so. It was kind of confusing because I was like, we didn't really talk about a T-score, but they say that this is a T in the lesson material. So that's the final answer. And if it's wrong, I'm going to think again and correct it.
How many questions are on this quiz?
18.
Yeah, it's not bad.
18?
Really not bad.
Okay. All right. Let me open up the document.
So yesterday on lesson 12, they talked about differences equals post minus pre. Second minus first, whether it's groups, pre or post testing, or anything, correct? So does that stand with today's, with the independent samples?
I don't believe it would.
We do differences still, because if we don't, there's no answers, there's no numbers, because we're still using, with the data given to us, we're still using the paired. Yeah, we're still using the paired sample t-test. Oh my heck! Are we using the clean sample t-test or the paired sample t-test for this week? I just saw this, you guys.
No, sorry, my boyfriend just sent me something and it's weird. Kind of. Oh my gosh. And he sent it to his mom too. Oh.
Okay.
Anyway.
Let me read up on all this information.
Wait, what are we talking about?
Number 6?
Oh, okay.
My biggest question is, are we taking that data and putting into the quantitative inference something? Excel stuff?
Yes. You can use that to help you.
Are we doing we're not doing the paired because it's independent, right? Are we doing paired or 2 sample t-test? Tabs on the bottom.
I mean, why don't you know? You should know this, right?
Yeah, let me just read the lesson. I just thought of that. Like, wait,
It's the 2 sample.
it
2
is?
sample. Yes.
Okay, I'm looking at my questions. Would that change? But what do you put in the assume equal variances?
Wait, what?
For the 2 sample t-test for means?
What?
What do you put in the, let's see, it's column 12F. Assume equal variances. No or yes? Oh, there should be no unless told otherwise? Okay, I'll just leave it. Then you have to go back and redo all those work. Okay.
It's going to be okay.
So I need Rexburg and Idaho back up here. So variable 1 will be Idaho Falls.
Wait, what? Oh, are you talking about the homework?
No, she's talking about the quiz.
And
The quiz?
Yeah.
so for number 6,
Oh,
since we're using the 2 sample t-test instead of the paired sample.
yeah.
Okay. I trust you. You took this before. You know everything.
If you fail, it's all Mary's fault.
No, it's not, because I don't even know what I'm doing. Okay, correction. I kind of do.
Okay.
I swear. Wait, no, correction. I don't. I really don't. It's been a long day.
Lots of things back. Okay. I'm doing this.
Okay, let's see.
Mm-hmm.
So I have the degrees of freedom as 37.996.
I have not done it yet. I gotta get my data here real quick. Where in the world did it go?
Come on.
I'm sorry. Where did it go? I have so many pages. Here it is. They're all hiding. Okay, so Rexburg is number 2. And that's gonna go here. I'm gonna do it. Oh, it's gonna have me. It's gonna go all weird on me.
So, hang on.
You ever take your pictures? Your engagement pictures?
Mm-hmm.
How'd it go?
It went really well.
Good.
Yeah, we already got 3 of them back. She knows that we need to get the invitations out, so.
Oh, that's good. You're your top 3.
Mhm.
So
Big enough?
exciting.
Okay.
Doing school during this time is so hard. Okay, so I put less than on type of test, no for assume equal variances, and then 1
It
is
was-
false to number 2 Rexburg. I got the same thing, 37
.996.
correction.
Yes,
Changing all my answers here.
right? Is that what we're looking for? Not equal to?
Less than.
Oh, less than?
Yeah, for number 6, it's a less than, and then it changes. It's like, what if?
Okay, so that just changes the p-value then.
Yeah, it just changes the p-values.
Okay, so sweet, we got the same answer. And that's the one that you guys were wondering about, right?
No.
No?
So, well, when I discovered it was a 2 sample, and then instead of paired, that's just what I was asking about. But
Wait, do we have to change the confidence or the level of significance on here?
where is that?
Would it be the confidence level?
No, I've never changed it before. and they don't
Okay. Right.
say either. So that would only
Right.
change the conference interval.
Okay, guys.
Yes.
I went ahead a little bit and realized that we have to find the test statistics. And I had a really hard time with this yesterday.
Mm-hmm.
How do you do it?
Well, in here, the test statistic is T.
Yeah, so you just write down the number.
That's what I put down for it yesterday on the quiz,
Mm-hmm.
and it said I was wrong.
Really?
Yeah, I think so. But I think I may have done it wrong anyway.
So real quick, the standard deviation for Rexburg is
The standard deviation is
206?
206.637.
Okay.
Yep. Anyway, I'll just wait till I get to that point.
Okay. Yeah, the test statistic. Yeah, I hate that word. It should just be T.
It is. I think what I think maybe talk about to Mary, correct me if I'm wrong, is when you have to like, just like the z-score, you know, the equation to find the z-score.
Yeah.
Similar to it to find the t value. And whenever I would do it, like with the full answer given in the lesson material, I knew exactly what, and my answer and their answer is never the same. Is that Mary? Is that what you're talking about? Because that never works for me either.
Probably.
I always get that wrong. I do exactly what they tell me.
But I don't know.
I am everything. It's quite dumb. So, do we put the negative in here with the test statistic?
Yeah.
Yes.
Is that what you tried?
For me,
Yeah.
I don't even remember because work was crazy. So.
Okay.
Value would be 0.333.
Wait, for the test statistic?
P-value.
For the p-value.
Oh.
So 33 and it's 10. A level of significance is 10. So it's greater, so you fail.
We failed to reject?
Correct, Sean.
Okay.
Now, if I'm wrong, just go and change your answers.
Just gonna hold it against you for the rest of your life.
Oh, yeah.
I'll cut my cords. So if we change hypothesis type of test to not equal to, it changes the p-value, but it's still greater, so it's still failing to reject everything, the hypothesis. So we would still have insufficient.
You sure insufficient?
Insufficient, but the two cities are different or the same?
Well, based off of their information given, they're talking about, first they say less than. There's no same there. There's even less than, which is still different, but it's less than. But that's not an option here. And then when they change the type of test to not equal to, that tells me that it's different. It's different than, this city is different than this city because they're not equal. So they must be different. But we don't have enough evidence to say that there is a difference between two cities. Is that correct?
Sounds right. I mean, you put up a pretty good argument for it, so I.
It sounds right.
Say that. Thank you.
It sounds right. How certain are you? I mean,
I don't know.
I'm agreeing with Sarah, but Weston sounds like
What?
you're doubting her.
No, it sounds right. She put up a really good argument for it.
Sounds right.
I don't know.
You. Is it right? Yes or no? I
I
think
trust you, Sarah.
like what else could it be? Because we're not either if it's less than or if it's not equal to, it would be different. None of our tests say that we're trying to figure out the same.
Mm-hmm. Yeah, you're right. Okay.
And then sufficient follows failing to reject. It follows to reject it. Correct?
Yes, ma'am.
Thank you. I like it. Okay.
Okay, this is why I like Sarah, because we're kind of the same, and we both beat up Weston over the
I
internet.
don't know why though.
I am not beating you up, man.
Okay, we're verbally abusive.
Weston, am I verbally abusive?
What?
Am I verbally abusive? I never saw myself as the Mary.
I plead the
All verbally abusive.
Oh man, we're
Sarah,
live
is
now.
there something you're not telling us?
I will tell you right now. So, because I love you guys, make sure when you put the Utah and Colorado information into your 2-sample t-test that you that you put Utah as number 2, not number 1.
Why?
Wait, for which one?
I don't know if that changes anything, but when you're doing the differences, it does.
Oh,
But
oh my gosh.
for the next,
Sarah.
You're right. You're right. That's the way that they want it in there. So
God has blessed me getting recently with this crap. I don't know why. Probably because I really pray hard, but oh, he's so good to me. Okay, where's my? There it is. This one's longer than the other one. There's not enough room on my little screen for everyone.
wait, what?
There's not enough room on my screen for everyone.
Oh, how is what?
Hold on. What just happened?
This is much easier than the other good value, Mary. I don't have a problem rounding this one up.
So for this one, we are saying that
Are you guys on 12 still?
yes.
So here we have different again. That word different.
So the appropriate alternative is not equal.
That's what I think.
That's what you put, Sarah?
Yeah, because it's just different. It's not.
Really, that's
I
your
don't think
argument?
I think less or greater even applies to this because they're saying they compare themselves different amount of times. Well, I guess they would, right? They consider themselves less days a week. But they're saying different times. Anyway. That's what I thought.
So on here, for the actual thing, the type of test, we put it to not equal to, correct?
Oh, yeah, correct.
Okay.
Good. Anyway.
So not equal to?
Yes.
Okay. Oh.
Okay, so it would be negative 0.845, right? And what are the same answers?
Wait, negative?
Negative 0.845.
Wait, how do you guys have a negative?
Did you put Utah second?
Yeah.
Not equal to?
Let me check again. Maybe I didn't.
I don't know why.
No, I didn't. I'm an idiot.
You're not. Not. You're a man. He's in love. It has to be in school. Can't be with his girl, woman.
What?
You're engaged and it's cool.
That makes more sense. All right, I got what you guys got.
Okay, good job. That's interesting. That does make a difference. And yeah, I'm glad we caught that. So that means p-value would be 0.411 to round up.
Yes. Mhm.
And before Weston, it was like 0.0598. I was like, how do we round? Anyway, so now I don't have to worry. So
Okay.
it's greater than the level of significance. So we do what, Maddie?
We checked the null hypothesis.
That's what I'm thinking. Because it's greater than what, 0.5 or 0.05?
Mm-hmm.
And yeah,
Are you thinking otherwise, Sarah?
Wait, what is the thingy again? What's the level of significance?
0.05.
Yeah.
This is greater. If p-value is greater than that. So the lessons always say you reject a null hypothesis if the p-value is less than the level of significance. If not, then you don't reject it.
Yeah, so the saying that they have in the lesson is when the p is low, reject the null. So
It's failed to reject.
yeah, fail. So does that mean that we got the other one right then?
The other one?
Yeah.
What number is that?
Reject.
0.33. Yeah, you're right. We got it.
So this is the 16 is where I'm trying to remember my brain. What we need to do here, because the margin of error was like weeks ago. This times this, but now I think I did that yesterday and it was wrong. So who can teach me?
I was wrong on this one too. So
I've never been good with margin of error.
well, we're all screwed.
First, let's talk about the information then. So determine a 95% confidence interval for mean 1, takeaway mean 2. An estimate for the difference between the two. And input your answers below. Huh? Okay. Let me see something here.
Or greater during the recess, so we're lucky to see it.
That's not good. obviously it's easy to put in the lower and the higher bound because they're right here on our Excel sheet.
Mhm.
So we'll just skip question 16 for now. Putting negative 5.147 as the lower bound because
Yes.
their total is 95%, and then 2.214. Because that's what I did yesterday, and it was correct. I just followed that. Oh, we're almost done. Okay, so the margin of error. What? They had us do. Okay, I'm gonna find it. It's Z. It was like a Z, but maybe it's a T now. We find the 95% number, which was like 1 point something.
1.645.
Close. 95, 1.96. And then it, let's see.
Oh, that's 90. Yeah, you're right. 1.96. And then it's the standard.
Times by standard.
Yeah, time or Z times standard deviation divided by. Oh, what you're supposed to do first is standard deviation divided by the square root of n times Z. So, do we have all that information in the?
Okay, will you give me the equation for f of the margin of error again?
What was that?
What's the equation to find the margin of error again?
So it's Z times standard deviation divided by the square root of n.
Okay, yeah, I found it now. So in this case, you have Z be the T.
No, so Z. So they have Z. They actually have actual numbers for Z. Since our confidence level is 95, it's 1.96.
That's the Z number? That replaces the Z number?
Yes.
Oh, I did not remember that at all.
I
Oh,
just
here
looked
it
it
is. Here's my notes. It's rip.
Come on.
Yeah, it says Z equals 1.96 in this case, using the 95% confidence interval. Hallelujah. So, which standard deviation do we do, though? Do we do Colorado or Utah?
So this site that I'm on says the standard deviation is the population standard deviation, and is the sample size. So I think since you're doing it for both, n would be what? 30, n would be 30. So I don't know what the standard deviation would be.
Wait, why is N 30? I'm sorry.
That's how many. Oh, if it's for everybody, there's 30 people that were, what's the word? Tested.
I only get 10 and 12.
Mm.
Look on the freshman. On the freshman. Yeah.
You're right. I counted wrong.
Okay, I was like, last time I was like double checking.
Because I was looking on the Two Temples t-test file, and it skips 1 through 4 and jumps straight to 5. So I was just looking off to the right and using those numbers to help count.
Oh, okay. That makes
Good job.
Thanks.
So with this
Glad you're proud of me, Mary.
What?
I'm glad that you're proud of me.
Who said I was? I could be telling you good job for your stupidity.
Oh, you could be. I don't see it in you.
you never know. Maybe sitting there.
Yes, guys. I'm drinking tea.
All right.
So, with it says determine a 95% confidence interval for 1 takeaway 2, an estimate. Do we go to the paired sample now?
No, you shouldn't have to.
I'm still confused.
To find the difference so that there's only.
Shoot.
Right, I'm probably confused anymore.
No, you're good. All right.
I just don't know what. Let me look at the video here.
Set the mean, the two are less sensitive. Using SPSS, we take this number divided by 2. But since it's a number that's close to 0, and I say close to 0 because it's not exactly 0, okay, it's 3 decimal places to the right. It shows 0, but they're pictures of the terms. Never going to be 0. That's in this case not close to 0. So that's why I have to here close to 0. So then the next step is, do we reject the null hypothesis? Will we compare a p-value to our level standard? Confidence intervals.
Okay,
Confidence intervals, let's produce confidence intervals here. Here's the very first confidence interval. So it was 1 mean, that was where we knew the population standard deviation. So we took a sample mean plus or minus the margin.
This is with the standard deviation known. But we're putting S in place of the standard deviation. Doesn't matter. Probably doesn't matter.
Do you know this one?
Like,
Usually, for margin of error, you take the 2 endpoints.
These two?
Yeah, you
And just subtract them?
minus that, and then divide it by 2.
Really?
Yeah, because each one is a margin of error away.
Guys, I found it on my own.
Wait, who is that girl? Thank
That's my
you.
fiancé.
Oh, yay.
we like you. We approve.
Weston, by the way, you didn't figure it out. Your fiance did.
But if I tell her that, then she'll start getting cocky. We don't need that.
Yes, we do.
Hey, hi. I found something too. What did you get? Like, I found T times SD. Same thing, but different.
It sounds more complicated.
Same thing as the V over the standard deviation, but different symbols for the matched pair thing. So,
I like Weston's way better.
you didn't tell us what it is.
I was like,
Weston, I found it. Hey,
Yeah.
tell me if I'm correct.
Okay.
Please. Time. What the heck?
No, you're not correct.
No! Go to the lesson 13 part 2 video of confidence intervals, independent samples. It tells you what equals. Okay, I'm showing you the screen. You guys just watch with your little eyes, okay? Watch this. Watch this.
If I'm not blown away, I'm going to be very disappointed.
Just, I'm not trying to.
I'm really disappointed.
Look at this.
It's basically
What is this? Huh? Huh?
I don't know. I can't see it.
Oh my gosh.
Too big, too big.
Too
Good.
small, too small.
Do you see? This is for confidence interval independent samples,
That's
which
for
is
100% though. We're looking for a 95.
does that matter?
Yes.
Well, does this apply for a 95 and 90
I'm-
as 100?
I don't think it would apply to 100 or for a 95, but you're along the right lines.
Because look, they don't show a 95.
Oh, Sarah. Nice effort. A for effort.
Wait, go back.
No, I'm serious, you guys. They are telling us what margin of error is with the confidence interval independent samples. And that same equation can apply for 100%, 95%, or 90%, or whatever other percent.
Okay.
Right?
Let's do it then. Let's do it.
Stop! You can't do that.
You seem super
You're gonna tell us-
confident about this.
Oh boy, you gotta tell me what we've got now and see what. No, we haven't heard yours yet.
No, so my fiance was just saying that what you should do is you should take the lower confidence interval and a higher confidence interval and subtract the two and then divide it by 2, and that should be your margin of error.
For real?
Yeah.
Where has she been all my life?
Right?
Why don't you have her around more often? Okay, so
Because she's always busy. She
Oh,
doesn't have
this is.
so repeat.
yell at her for you guys later.
Hi, Ian. How are you? Nah.
Let's repeat this, Weston.
How was it?
Weston. We take
Yes,
the
ma'am.
lower one or the higher one first.
The lower one.
So negative 5, 5.147, and then you take away.
It's pretty much adding.
Basically, but should I put in the takeaway?
Help, I'm lost again.
Take away 2.24. Divide that by 2.
Hmm. That's what she says. I
Wait,
don't know how right that is.
We should try both.
Are you sure
Wait.
that's right?
I'm confused.
Margin of error?
Yeah.
Show her the video.
2 minus negative 5. I'm pretty sure it's right. I thought so. That's what we did.
Stop laughing at us, Mary.
No, I'm not laughing at you.
Then we also
Wait, you did. I'm doing it wrong.
I'm doing it wrong. I did exactly what you did.
2.214
yes,
minus negative. It won't be negative. Negative 5.147 equals that number divided by 2. That should be right.
Hello.
Hi.
Weston.
If it's not right, I'm sorry, but what's your idea?
Weston.
Yes.
Weston.
Yes.
Show her this. Yes.
Hold on. Let me. What about it?
Wait, what?
I don't know what all those symbols mean.
Ah!
This is so awesome. This is so making sense. Except for, do I do all of this and then I get the square root number of all of it, or just the number?
Yes. The square root number of all of it.
Yeah, I'm doing it, and I'm gonna see what the difference is. Okay.
Bye, Ian. No.
She said,
Sarah, I hope this helps you.
what? What helps me? You should see what she says about this guy.
What?
Oh my heck, this is crazy. Okay.
So this says it's supposed to be, but we don't have the sample means for the first places.
Huh?
How are we supposed to get the, at the very top it says the summary statistics, the mean for Colorado and the mean for Utah. We don't have that information. How do we get that information?
The
Oh, I've never messed with that yet. I don't think it's required because we're not, it hasn't been
That's what it says.
given to us in the lesson, so I don't know what to put in it.
But if you look at that slide, it says x1 equals the first sample mean and x2 equals the second sample mean.
Isn't that this?
Shoot.
1 and 2. Okay, so do I need to do the whole squaring stuff first? I probably should, shouldn't
Mm-mm.
I? Okay,
Well,
so
You need to square it and then you multiply it by t.
okay. I'm gonna square this sucker. It's 15, right? 15.
Hey, real quick.
Yeah.
Oh, never mind. Don't do the x1 minus x2 portion, just the bottom one. If that makes sense. It probably didn't make sense.
The standard deviation point, not the sample means. Don't do the x's.
Yeah, don't do the x's.
Just
Because that's how you get the confidence interval. The bottom one is how you do the margin of error.
correct. So
the
just
confidence interval is already in there, though.
Yeah.
Weston, are you okay?
Yes.
Are you sure?
Just tired.
Same.
I'm doing this. It's a long number.
Oh my gosh.
Wait. And so for T, it says use the confidence or levels of confidence and degrees of freedom.
Huh?
For T, it's telling you to use two different numbers. How do you do that?
I could listen to his voice.
Okay.
Standard deviation squared here, which are covariances, but standard deviation as well as the sample sizes. To get everything combined would be you would be calculating this using SPSS or Excel. Okay. So let's go back to the first example. Groups.
No, come back.
Oh my God, these 5% difference. We cannot tell if they're based on our risk to be positive using carefully group up. Actually, my second difference is not
Dude.
as well as the sample size. So the confidence interval today, here's the formula for it. It's not in the textbook, but it's basically, I point this out to show you that it's still a point estimate, plus or minus a margin of error. Our point estimate is
We know.
and then we add and subtract the margin of error where we still use the t-distribution to get our critical value. And then we also have standard deviations, standard deviation squared here, which are covariances. Sample sizes. To get everything combined would be our margin of error. This is what we put this down here. Okay. It's also calculating SPSS or Excel.
No, it's just inappropriate. Let me see a picture of the
So let's go back to the first example that we covered during the hypothesis test. Now we're going to look at this in terms of confidence. So if you remember, there were two groups. Those results I get or greater through.
So
and I'm gonna
I'm
grab
just gonna say
then-
that I use
it's just
the
gonna be
T
well,
value.
it's not really the same. And then it's same with this confidence interval. We go with match pairs where we
I mean, we can just make it the confidence level.
show you.
It's probably, the equation's probably something where it's if you don't have the confidence level, but you have the degrees of freedom. Or if you don't have the degrees of freedom, but you have the confidence level.
I like that. I like that. Um,
So it would be can we see the equation again, Sarah?
She's on mute.
Why is she on mute?
very
Her husband's probably home.
Oh,
No, he's not home yet. He just got off work. Okay, so here's the equation.
okay. So
I
it's,
am. Hey, I got it. And then you do the whole square root number of everything. Ah, not that hard. I mean, all I have to do is ask Siri, but it's great. Great. Okay. Oh, flip. Let's just look at this real quick. Am I okay to stop screen sharing?
hold on. Yes.
Okay. So this is what I came up with. And I numbered them 1 and 2. That's all that is.
Hold
So
on. Did you do that right?
tell me if I did it right.
So the standard deviation shouldn't be that big.
I did it again. The first one, 4.517. Square root x2. 20.
Yeah, so it should be 4.517 over.
But that's the square. It's the. I'm not square root of. It's the power of 2. Right?
Oh.
You know how they both have little 2's above
Yeah.
them?
Yeah, you're right. Yeah, you're right.
Okay.
Sorry, I didn't see that part.
All good. All good in the hood. So now I need to. Should I just focus on adding these together?
Do the division first, and then add them together, and then take the square root of everything.
Oh yeah, division to simplify it.
Mm-hmm.
Divide these, get the answer. Divide these, get the answer. Add them, get the answer. Times it by, then find the square root, and then times
And
this
then-
by the square root. Oh my heck, okay.
Yes, ma'am.
Everyone got it?
No. You kept moving. I only got the first. Oh, my Lanta.
You own Atlanta?
No, Weston, I got it off of Full House and Fuller House. Hence the reason why, oh my Lanta.
I'm just seeing if this is the same as the one your fiance gave us.
Yeah, she's probably wrong. She did not like that one. She definitely looked over.
Square root of 6.45208.173. He doesn't see any matching restaurants.
What?
I asked, he said, I don't see any matching restaurants. And I asked what the square root of that first number is. What is
Sarah.
173?
Sarah.
What?
What's the number?
911. What's the number? What's the number? Have you seen that? Okay, I'm sorry. Just go to your Excel to simple and get all the numbers.
No. Just tell me the numbers and I'll put it in my calculator.
Well,
Sarah.
they're right here, putting your face on the screen. This thing. And this example.
Drop mic and walk away.
I need the number too. Square root of 6.4520817. You got it.
Wait for.
You should
Oh
just
my.
wait until we get the final answer if you're gonna do it.
Fine.
I'm
Drop pencil.
just trying to write down my notes. Where is it? Oh, my nose itches. Square root of 3.37646142. Square root of 3.37646142.
I got you, Karen. I got you.
Thank you.
I kept saying I thought I was asking you.
If I can climb over my stuff. No, I'm just.
Oh, okay.
Right? So
That took forever.
I divided and got these numbers.
Wait, Sarah. Hey, wait. Whoa.
Oh, we're done.
Whoa.
So what'd you get?
Well, now I'm adding the two square rooted numbers together.
What the heck?
What?
Wait, no, you add them together before you take the square root. Yes.
Is it two different answers if I did it that way?
Yeah, you come up with two different answers. So,
So you put the divisions together before. Oh yeah, because that comes first.
you divide, then add, and then you take the square root and then multiply.
Okay, I'll be back. Thank you.
What are you laughing at, Mary?
What? What are you talking about?
You laughing at us?
No.
We should just laugh at Sarah.
I'm heading to China.
Not so
Okay.
9. I love you.
Yeah, I'm going to shut it down.
We're almost done.
Square root of 9.828544315. Ah, Weston. Did your number start with a 3 and end with a 4, ...
It started with a 3.
Point
Oh,
one
wait,
three.
my final answer?
No, your square root of. Now I'm timesing.
I got 3.0150.
For the final?
No, for the right before you multiply by the t.
The square root?
Yeah, so what numbers did you add together before you took the square root?
This one and this one.
Wait, question. Do you do the square root before you multiply?
Wait, hold on. Wait, what was that, Mary?
Do you find the square root before you multiply?
Yes, take the square root, then multiply. Why did you use those numbers below in the square root?
So these numbers are these two. This divided by that is that.
Wait, no, but why did you... So I understand...
Yeah. Okay, what?
I understand why you have the number up top, but where did you get those numbers on the bottom?
These one?
No, go up. Up. Yeah, that one. The divided number.
Oh, that is.
I do my side, I do it.
We'll see in a little bit, Sarah.
That is the square root of.
Okay.
Oh. Why did they do that? I don't know. I'm used to it.
All right, let me...
Is that it?
Weston, I just have to divide it by a 10
Okay.
and a 12.
Wait, hold on.
Right?
So why did you use those numbers now, Mary?
What?
The ones below.
What are you, what are you talking about?
So in the square root equation, the numbers that you have on top that are supposed to be divided by the ones below, why did you use those numbers?
Those are the numbers I got from Sarah.
That's right. You do your own work, you fail.
guys, n equals the first sample size, or n1 equals the first sample size, and n2 equals the second sample size.
Oh, but guess what I did?
What?
Square root of number 10 and number 12 because that's what I'm used to doing. So just be a 10 and a 12. That's it.
Yeah.
What am I thinking? I'm not.
Weston.
Rusty. I mean, Mary.
What?
I'm excited that she thinks, or that she got the margin of error equation. She does the whole thing. Find out she did it wrong. Or that she did one portion wrong. So she's like, "Oh, that's an easy fix. I can do that real quick." And then she shows me the answer. And it's like way off. She's like, "Where did I go wrong?" I was like, "Why did you use those numbers right there?" She's like, "I took the square root on accident just to start all over."
Not.
But Mary took all of her numbers as well, so Mary has to start all over too.
That's awesome.
Weston, be nice,
I
okay?
am being nice.
There are some things that you are. You're. I don't even have the words to explain it, but you're like.
I didn't do anything. Okay, hold on.
Yes, sir.
Wait, I didn't
Hold on to what? Hold on to what?
10, 12. Okay, go down. Yes. Yeah, that's what I got.
And now I need to plus those together. No.
Yeah, you add those together.
And then
you
square
take
root.
the square root.
Help.
You can do it, Mary.
No, I'm giving up at this point.
Our last question before we get off the tent.
Yeah, that's the only way you can stop the flu.
3.01502 something something.
Huh?
Yes, that's what I got when you add them together.
You do it very good.
Oh, that's a good question. They're trying to make me think this is too far. Policy.
Root of 3.015028
Chapter goes like once a week on Saturdays. That's it? Yeah. The reason I took this is because I'm coming to Chandler Regional, which is part of the big meeting. I work there like 2 times a week.
Now I'm timesing
Genius.
a T score. A T value with it.
You're almost there. That's the easiest part.
Weston, this is your second time taking this class. Don't even. You already know
I
what
told
you're
you
doing.
though.
Will it help that algebra and
Well, I was just saying that the multiplication part's the easiest part of this whole equation.
Yeah, they should be able to come to your law and do it. Because there are people that are on this side of town.
What was that, Sarah?
But I love the whole equations, like breaking it down, everything. I think it's really fun.
Why did you mute me?
Oh, I'm sorry.
How did you do that? That's so
I couldn't
Weston,
hear Sarah. I couldn't hear Sarah. I thought she was asking me about the question.
I wasn't doing anything.
No, we can pick up the conversation that's going on in the background. No, you're good.
No.
That's really funny. How do I undo it? How do I undo it?
How do you mute people?
Weston!
Why?
Oh my goodness, Weston.
Hey, Weston, I got the number.
Okay, what'd you get?
Is it a negative number?
Yes, ma'am.
1.4 something?
Yes, ma'am.
What?
And it has a 7 and a 2 and a 6 in it?
Yes, ma'am.
And
Not in that order, but there are those.
Okay, I'm good. I'm really good.
How?
So, Mary, did you want us to explain?
Yes.
Okay, cool. So, I'm doing this all on a napkin.
I have a question real quick. Do you have to round it to 3 decimal points places?
I believe so.
Okay, then I'm done.
Okay, so
Oh my gosh.
I really want someone to watch this and just This is probably the funnest, and it's 18 hours. Probably the funnest.
so this is the equation, right, Mary?
Yeah.
Okay. So what you do with the information that you're given, you are told what the standard deviation is for the sample 1. Do you know what that is?
Mm-hmm.
What is it?
No. Weston, I'm completely lost right now. Are we still doing the margin of error?
Yes. I'm showing you how
Okay.
to set it up.
Okay.
Okay, so what is the standard deviation for variable 1?
Standard deviation 4.517.
That for S1 squared. So for that one right there.
Wait, you're hidden. For where?
For that one right there.
Okay.
Okay. And what's the standard deviation for variable 2?
3.420.
Okay, now you put that in for the second one.
Okay.
Okay, so now for N1, how many people were part of the test for variable 1?
10.
Okay, and how many were in there for variable 2?
12.
Okay, cool. So the
And negative 845.
0.845. Yep, you're right. And so the way that you're supposed to do this, they actually show you in the equation that the standard deviation for variable 1 and 2 need to be squared. So that's
Okay.
just 4.517 times itself.
Crap. Hang
Did you already submit it?
Can I submit what?
Did you already submit it?
I was just gonna ask if I should.
If you want to.
Oh, okay. I'm back. I left my calculator.
Okay.
Uh,
So just, what was that, Sarah?
Will you be submitting it soon?
so that's 20.403289.
Let me check. Yes. Okay. And I'll do the same thing for the 3.420.
I'm gonna submit it, and I'll tell you all if you're wrong. If we
Okay.
are wrong.
Got it.
And then that one's 11.6964.
Perfect. Okay. And so you keep the equation correct?
Mm-hmm.
What's up there?
And then you divide it by 10 and 12.
Yep.
Huh?
Well, the list is, you don't want that.
And that one's 0.9747.
Yeah, for the 11 one. Okay. What about the other one?
The other one's 2.04.
Yes. Okay. So before you can do any multiplication, what you have to do is you have to add those two numbers together.
Uh-huh.
Okay. So let me know when you get that answer.
Okay.
And then that one's 3.015029.
Yes. Okay. So now you take
So
the
then you
square
square
root of that number. Yeah.
And that one's 1.736383857.
Yeah. And then you multiply by the negative 0.845.
Guys, have a problem.
And that's negative 2.054. 892.139.
Stop you.
Wait.
Wait, what?
So, I'm gonna share my screen with you. This is what it says in the quiz result, or the
On the
quest,
feedback.
the quiz result. So I got 0 out of 1 point for this one. The one we're just
Okay.
working on. And this is the feedback. I need someone to translate.
So we don't use SPSS now, right? Everything that they show us is on Excel.
Right.
So I'm starting to wonder if it's the answer I just got.
Why? What answer did you get? What is it?
I got negative 2.05892.139.
And what is that from?
That's the one we just did. 16.
How did you times it by the t
Yeah.
value? So how'd you get a different number than Weston and I?
I don't know.
So you got the square root, or you got the power of 2 for both standard deviation, divided by 10 and 12, and then you added those two together, and then you got the square root from those two added together, which was 1.736 something something,
Uh-huh.
and you times that by the negative 0.85 or 845.
Wait, negative. Yeah.
you have your numbers written down, Mary, to where you can like do and like just do the ending part again?
It's, ooh, wait, where'd it go? It's that
Okay.
part.
I see.
It's very hard to see.
Yeah, I mean, everything looks right. I just don't know how she got that answer.
Put we did 1.736. Then you times that by the t instead of timesing the t by the other one.
Well,
Would that make a difference?
since I have a scientific calculator, it should be the same thing as everything else. Or at least somewhat close.
How do we do on everything else, Sarah?
Aced it.
Yeah, it's just that last one.
Just that one, yeah. So, and then if you can see this has feedback. And this has feedback, but the answers are right. So, and it says the same thing. You see?
Mm-hmm.
So it must just be that that's what they're choosing to do for these last three. But the fact that we just got it wrong. Do we want to go back? But if it's lower in Excel, it should be a lower number? Because we could either someone could go back after they submit it and try Mary's answer, and someone could try your fiance's answer. Or we can
Remind me how to do like the upper and lower bound.
it's just from
it's the confidence interval numbers that were given.
in Excel.
Okay, I'll do hers.
You're gonna do your fiance's? Watch her be right.
Yeah.
And then she'll be like, remember that time?
All right. So the way that you said to do it was 2.214 minus.
Minus negative 5. Was I right?
Okay, I'm gonna submit mine.
What answer are you putting in there, Molly?
Negative 2.058.
Yeah, I'm curious to see what it ends up being because if we don't get it, then
All right.
whoa, I got a different answer for your fiance's way of doing it, Weston.
Yeah, what did you get? A 3.681?
Oh, mine's wrong too.
Well, I got that the first time, and then when I do it the other way around, I get a different answer.
Okay, I'm going to submit it right now.
So we have to take away 2.214 take away 5.147.
Hey, what did you get for 17?
For 17?
5.147.
5.147?
Negative 5.147.
That's what I put, and they said I got it wrong. Oh,
I put negative 5.
I put a comma instead of a period.
Oh,
I got 17
Hey,
wrong.
but she was right about 16.
you was?
Yeah, I was.
But don't tell her she's right.
So it's a negative 3.6805.
No, it's just 3.681.
Wait, what did you guys get for 17 again?
17, it's negative 5.147. You may have done what I did and accidentally put a comma instead of a period.
Oh, I didn't put the 4.
Oh, never mind.
She missed the whole number.
No, yeah, so the answer is, how did I even do that? Shoot. It was 2.214 minus negative 5.147 divided by 2, and that's how you get the answer.
Well,
5.1.
yeah.
But yeah, everything else is right, guys.
Yeah. I'm good with my grade. I'm sticking to it.
But all you have to do is just go back and change the one answer.
I'm doing it. No way, man.
No, I'm good. I'm good. I'll
Okay.
keep it.
Okay. Well, cool. Good job, guys.
Been real.
Yeah.
Next time is out.
All right. I'll see you guys later.
All right. See you guys next week.
Bye.
Bye.